In section 9.1, we're going to talk about matrix solutions to linear systems. Basically, how it's another method. We're going to learn another method of how we can solve a system of linear equations in 2 or 3 variables by using a method called Gaussian Elimination with Back Substitution or Gauss-Jordan Elimination. Those are two different, that Gauss-Jordan is just an extension of it. And both of them require, of course, matrices. So the first thing we're going to learn in section 9.1 is what is a matrix. Now, a matrix, matrices are used to display information and to solve systems of linear equations. A matrix, or matrices in plural, it is a rectangular array, and the information is arranged in rows and columns and placed in brackets. The values inside of the brackets are called elements of the matrix. So, for example, if I have this matrix right here, it is enclosed by brackets and it contains only numbers, like it says. The number 1, it is basically the value in the first row, first column. The number 2 is located in the first row but second column. The number 3 is in the second row, first column. The number 4 is in the second row, second column. So it is arranged in terms of rows and columns. That's what a matrix is. It's just a rectangular array with numbers in which every number is called an element of the matrix. Now, this is going to be the main concept of matrices that we're going to use for solving systems. It is augmented matrix. Now, what's an augmented matrix? Is basically the first step in solving a system of linear equations is write what is called the augmented matrix. So the augmented matrix is the matrix that corresponds to a system of equations. Basically, when you write a system of equations into a matrix, the coefficients are placed into the, you're going to place it into 2 groups separated by a vertical line, and the coefficients of each variable are going to be placed to the left of the vertical line, and the constants are going to be placed to the right. So, for example, if I give you a system of equations, I'm just going to put it in general. AX plus BY equals to C, and DX plus EY equals to F, then this is how the augmented matrix is going to look like. There is going to be a vertical line right here, and just to give you a better idea, the vertical line is nothing else but the representation of your equal sign of your system of equations. So the coefficients are going to be on the left side. The coefficients means the numbers of the variables. The coefficients, the numbers in front of the variables, which in this case is the A, B, D, and E, the X's and the Y's. Those are the coefficients. Those are placed on the left, and the constants are placed to the right. This is what we call an augmented matrix. Now, let's go ahead and write the augmented matrix for this system of equations here. Write the augmented matrix for the system of equations to the right. So, as we can see right here, the first equation contains all x, y, and z, meaning that we just need to look at the coefficients. The coefficients for these as 1, this is a -1, okay, so we have a 1, a -1, then a 6, and the constant is a 10. The constant goes on the right side. Now look at the middle column. There is no, the middle row, I'm sorry, there is no x, meaning that the value of x is 0. So we're going to put a 0, then the coefficient of the y is a 1, then a -4 for the z, and then a -8 for the constant. Now, if we look at the last row, there is no x or y, so that means that both of them are zeros. So we have a 0, then the z has a value of 1, a coefficient of 1, and then the constant is a 2. So this is the augmented matrix for this system of equations. For the next problem, I want you to do the opposite. Now, if I give you this matrix, this augmented matrix, I want you to write the 3 equations that represent this matrix. Of course, using x, y, and z as the variables. Keep in mind that the first column always, right here, always represents my x. The second column represents my y. The third column represents the z's, and the vertical bar represents the equal sign. Right? So what does the first equation tell me? So it is 8x plus 0y plus 5z equals negative 13. Of course, since there's a 0y, we don't have to write it down. We just write it as 8x plus 5z equals negative 13. That's all we have to write for this. Now, second equation. You see that there is no x, so we're going to put a 0x plus 1y minus 6z equals to 15. Two things that we can fix here. The 0x, we don't have to write it. We're just going to put y, but instead we don't have to put the 1 either. So y minus 6z equals to a 15. And the last one, you see it is a 7x plus the 2y plus the 0z equals to a 3. We don't have to put the 0z, we just put 7x plus 2y equals to 3. And this is a system of equations for that augmented matrix. Now, the next thing we are going to get to is called row operations. Row operations is basically what you are going to use to solve a system of linear equations using Gauss-Jordan elimination or Gaussian elimination with back substitution in this section. So, what does it mean by row operations? So those are three basic operations that you can do with the rows. The rows are your horizontal lines, which basically every row in a system of equations, when we see it, this row represents my first equation, the second row is my second equation, and the third row is my third equation. So when I say row operations, means operations with equations. Now, in the matrix, there are three operations there's only three operations that you can do. Operation number one, in a matrix, in a system of linear equations, in an augmented matrix, you can interchange two rows. What does it mean by interchange two rows? Means that the first row you can send it to the third row, and the third row you can send it up to the first row. Or the first row you can send it up to the second row, and the second row you send it to the first row. You switch them, basically. And these are the symbols we're going to use for switching that I want you to keep in mind. When I say interchanging elements, then the ith row and jth row, then it's going to be Ri, double arrow, Rj. That means interchange when I put the double arrow. Okay? Next, let's go back. Second operation that you're allowed to do in the matrices is the elements in any row can be multiplied by a number. Okay? When I say the elements of a row can be multiplied by a number, it means that both sides, you're basically multiplying both sides of an equation by a number. That's basically, because remember, a row represents an equation. Okay? So, how do we represent the multiplication? Very simple. This is how. If I say that I'm going to multiply each element in whatever row by a number k, it will be k times that row. K-R-I, whatever row that ith row is. Okay. And the third and last operation that you're allowed to do in the matrices is this. The elements in any row can be multiplied by a number, and those products can be added to the elements of any other row. If you keep in mind, rows are equations. When I multiply a row by a specific number and I add it to another row, that basically talks about this, that we cover in section 5.1, the addition method. That is basically what this is referring to. Remember that in order for me to cancel a variable using the addition method, What did we do? We needed to first make the values, whether the x's, the y's, the z's, whichever ones you wanted to cancel, you needed to make them the same number by multiplying one equation by whatever number, so that when you add it to the other one, it equals to 0. That's exactly what this is telling you. So multiplying a row by a number and then adding it to another row is just basically the addition process that we're mainly going to use to, whenever I ask you, we're going to cancel this variable, which is the same thing as saying that I'm going to make this number into a 0. Okay. So how do we represent multiplying an equation by a number, a row by a number, and then adding it to another row? It is like this. For example, if I say add k times the elements of row I to the corresponding elements in row j, is k ri plus rj. Means multiply this row by that number k and then add it to this other row. That's how we represent multiplying a number, a row by a number, and then adding it to another row. And keep in mind, these are the only 3 operations that we can use when solving systems using Gaussian elimination with back substitution, using matrices, which is what we're going to learn today in this section. Okay, let's go ahead and begin with the row operations. So I'm going to give you 2 row operations, and then we're going to start with the solving. First question here says, perform the following matrix row operation and write the new matrix. So what does this tell me? This is my augmented matrix 2, 6, -4, 8, 6, -4, -1, 0, 4, 0, 2, and -3. So basically, what does it tell me here? That 1/2 R1, that's what I want to do. That means multiply every element in the first row, that's what the R1 is, by 1/2. You can either say it in a different way. When I say multiply the numbers in the first row by 1/2, that's the same thing as saying divide all the elements in row 1 by 2, right? So you can either do it either way, which is the exact same thing. So for example, if I take those elements, I'm going to put my row operation right here on the side, okay? If I take those elements, 2, 6, -4, and 8, and I multiply them by 1/2, meaning that I divide them all by 2. If I divide them by 2, that is going to give us the elements 1, 3, -2, and 4. And this is going to be the key for this particular part. I want you to look at this number right here. That's a 1. In the next part after this, I'm going to ask you, okay, how do we, what do we have to do to make this number into a 1? Because basically, Gauss-Jordan elimination or Gaussian elimination with back substitution consists of reducing the rows into 1s and 0s. That's something we're going to do. When I say make a number into a 1, that basically means, we want to make it into a 1, what operation do we have to do? One of the things that you can do is multiply the row by the reciprocal of whatever number that you want to make into a 1, or divide the whole row by that same number. That's how you make a number into a 1. We're going to talk about that in the next part. Okay? So, right here, let's go ahead and write the new matrix of my result right here for the operation that we applied. So on my first row, we multiplied by 1/2, which is the same thing as dividing by 2. So my first row became 1, 3, -2, and 4. And we're just going to bring the other 2 rows, which is 6, -4, -1, 0, and the last row 4, 0, 2, and -3. So this is the new matrix with the resulting row operation, which is by multiplying the first row by 1/2 or dividing the first row by 2. And I just want you to keep in mind what we did right here with the first value. We turned the first value into a 1. Okay? Keep that in mind. Let's do one more row operation. The next row operation that they want us to do is this. For the middle row. This is for the middle right here. What they want me to do is this operation, negative 8R1 plus R2. And that we're gonna do it, we're gonna use that operation to change the values of this middle row, which is where this is pointing out to. It is pointing to the middle row. So that's the only modification we're gonna do. Keep in mind, just because I multiply negative 8 times row 1 and then plus row 2, that doesn't mean that I'm going to change those values by multiplying them times negative 8 and write those new answers. No. This operation is going to be one operation altogether, and it's just going to be used to change the values from this middle row only. Okay? So, we need the two rows 1 and 2. That's what it's telling you to do. Use row 1 and row 2. So I'm going to put row 1 on the side, right here. And with row 2, which is this one. 8, 8, 6, and 4. So what this is telling you to do is that you're going to multiply negative 8 times row 1. So basically that means you're going to multiply everything in row 1, which is this one, by negative 8 first. And that's going to give us negative 8, negative 56, positive 24, and positive 8. And then what does it tell me to do next? Then it says that you're going to add those answers to your row 2. And your row 2 is this second row that we had. 8, 8, 6, and 4. So if I add these results, we're going to get the following. 0. This is something that I want you to keep in mind. 0. Negative 56 plus 8 is negative 48. 24 plus 6 is 30. And 8 plus 4 is going to be at 12. So that means that the new values for the middle row, just the middle row, are going to be the 0, negative 48, 30, and 12, and I'm just going to bring down the other two rows that we originally had, which is 1, 7, negative 3, negative 1, and negative 7, 3, 6, and 1. So there's a purpose for this operation that we did, and this operation basically it was to make that a number of 0. So that's one of the things that I told you that in the Gaussian elimination with back substitution is going to consist on, reducing the rows into 1s and 0s. Now, when I said make a number of 1, I told you we're going to multiply by the reciprocal or divide everything by the same number. Now, if I want to make a number into a 0, we're going to use the process of addition. If you remember, what does the process of addition consist of? Multiplying one variable, one equation by a number, so that when I add it to the other equation, it cancels. Cancels means that it becomes a 0. Okay, so when I want to make a 0, this is what we're doing, the process of addition. And as you can see, if I added the first and the second row, I needed to multiply the first one by negative 8, so that when added to the second one, it equals to a 0, or it cancels out. Okay, so, and that's what made it a 0. See? So now I'm going to show you, with that in mind, how do we make the 1s and the 0s? Yeah, I already told you. Now, how do we solve a system with Gaussian elimination? This is going to be the main topic of the section. Solving systems of linear equations using the process of Gaussian elimination with back substitution or Gauss-Jordan elimination. So first of all, we're going to start with the Gaussian elimination with back substitution. Step number 1 is going to be that you need to write the augmented matrix for the system. After you write the augmented matrix, the next step in the process is this. That first, you need to make the top number right here into a 1. You need to get that 1 in the upper half. How do we make that into a 1 if it's not a 1? Basically, very simple, by multiplying by the reciprocal of that number or dividing by itself. Remember, if I multiply by 1/3, that's the same thing as dividing by 3. Or if I multiply by 1/4, that's the same thing as dividing by 4. Whatever that number is, if that is a 5, let's say, I can just say divide everything by 5, or multiply it by 1/5, which is the exact same idea. Now, second step in the process here is going to be that you need to make the two numbers right below that 1, you need to make them into zeros. Now, to make them into zeros, you're going to use the process of addition, because a 0 means that you're going to cancel each one of them. And now, this is the key. If I want to make them into zeros, you need to always use the process of addition by adding it to another equation. And that equation will always be the equation that has the number 1. So if I want to make the second number a 0, I need to add it to the equation that has the number 1, which is the first equation. As you go to the previous problem, that's exactly what we did. To make that 8 a 0, I added it to the equation that had the 1, which was the first equation. Likewise, if I wanted to make that -7 into a 0, I needed to add it. I need to add it to the first equation, which is the one that has the number 1 that we turn into a 1. Okay, so that's exactly what you're going to do. So if I want to make this a 0, I use addition by adding it to the first equation. If I want to make this one a 0, I add it to the first equation. So that's basically what you are going to do to make them into zeros. And if you go to the row operations, that is your operation number 3. To make them zeros, that's exactly what you do. Okay. Now, what is the third step in the process? Now you need to make that number right in the middle into a 1. Now, how do we make it into a 1? By multiplying by the reciprocal of that number, or dividing the whole equation by that same number, which is the same thing as multiplying by the reciprocal. Okay, that's how we make it into a 1. Now, step number 4. After you make that middle number a 1, you need to go to the bottom one, the one below that 1, you need to make it into a 0. And just like we did on the previous one, if I want to make that into a 0, I need to add it to the equation that we just turned into a 1, which is to the middle equation. You always add it to the 1. Okay? Now, fifth and last step, I need to make the number in the corner into a 1. How do I make that number in the corner into a 1? By either multiplying the whole equation by the reciprocal of that number, or by dividing the whole equation by that same number. And that's how we turn that into a 1. So these are the 5 steps that we're going to follow to solve the system using the process called Gaussian elimination with back substitution. Now, I'm going to show you the back substitution part. So first of all, we're going to go through these 5 steps in the next problem, then I'm going to show you the back substitution. Okay, let's start with this. Solve the system using matrices. Use Gaussian elimination with back substitution or Gauss-Jordan elimination. Now, I'm going to show you the Gauss-Jordan elimination on another problem. So right now, I'm just going to do the Gaussian elimination with back substitution. First thing we're going to do is we're going to write the augmented matrix for this system of equations, which is 1, 1, -1, and -3 for the first row, 2, -1, 1, and 3 for the second row, -1, 4, -3, and 1 for the third row. So, and the process of the Gaussian elimination is going to consist of what we call row operations. So I'm going to be writing the row operations on the side as we go. Okay. First step in the process is for you to make this number into a 1. But it is already a 1. So we're going to skip that. Okay. We're going to go to the second step. Second step in the process is that I need to make the two numbers below that 1 into zeros. Now, we're going to do one at a time. Okay, so I'm going to prepare my new matrix right here. The first one is already going to stay like that. So we're just going to work on the second one. Now, let's start with the 2 right here in the middle. So if I want to make that a 0, you need to make a number into a 0, you're always going to use the process of addition, meaning that you need to add it to another equation so that you can cancel that out. And you're always going to add it to the equation that has the 1, or the equation that you made into a 1, which is to the top. Okay, so I'm going to add this first and second equation. So keep in mind that this one represents my x. This 2 represents my 2x, because the first column are my x's. We talked about that before. So this is 1x, this is 2x. What do I have to do so that these two x's cancel? Because remember, the goal is to make it into a 0. First, I need to make them the opposites of each other. In other words, if I want to make this the opposite of 2, I need to multiply it by -2. And that's exactly what you're going to do every time you want to make a number a 0. You're going to multiply the equation that has the 1 by the opposite of the other equation. Okay? So if I multiply all of this by -2 right here, we're going to get -2, -2, +2, and +6. -2 times -3 is +6. Then what you need to do now is you're going to bring this second equation right here, and the process of addition is that tells you that now you're going to add the two equations. -2 plus 2, it's a 0, which is what we wanted to get right here. -2 plus -1 is -3, so that's the next value here. 2 plus 1 is going to be a 3, which is the next value here, and 6 plus 3 is going to be a 9, which is the next value right here. Now we're going to follow the same operation. Well, before I jump to that, I want you, just like with the R1 and R2 and R3 that I showed you on the row operations, I want you to write me an equation for that middle row that we just changed into this, based on row 1, row 2, row 3. What are the two operations that we used right here to get that row? First of all, we multiplied -2 times these values right here, and those values are the values in my row 1. So we're going to say we multiply the first row by -2, and then we added it to this row, which is the values in the second row. So then we added it to the values in the second row. That is the equation we use to obtain those new values. Next, now we want to make that -1 into a 0, and we're going to follow the exact same process. To make it a 0, to cancel it, we need to add it, use the process of addition, and you always add it to the equation that we made into a 1, which is going to be to the top equation. So we're going to get another pair right here, and it's going to be my first equation and my third equation, which is -1, 4, -3, and 1. So if I want to cancel these two out, or in other words, if I want to make these to a 0, what do we need to multiply here so that they cancel? Nothing, because they already have the same number and opposite signs. So all I have to do is add them out, right? 1 plus -1 is 0, so they already give me a 0 right there. 1 plus 4 is a 5, so I just add the rest. That's a 5. -1 plus -3 is a -4. And the last one right here is -3 plus 1, it's a -2. So we put the -2 on the bottom. So that gives us the first two steps. So on the first step we needed to make that a 1. On the second step we needed to make these two zeros. That's already done. Now I want you to do one last thing, which is write the equation in terms of row 1, row 2, and row 3 of what we did to get these new values in the third row. So this is the operation we used, which is all we have to do is add the first row to the last row. So it was row 1 plus row 3. So we did step 1, which is make the top number into a 1. Step 2, make the bottom two numbers zeros. Now we're going to jump to step number 3. Step number 3 is going to be to make the middle number into a 1. That middle number must be turned into a 1. To make it into a 1, like I said, you're going to multiply the whole equation by the reciprocal of that number, which is you're going to multiply the whole equation 2 by -1/3. So row 2 times negative 1/3. That's the reciprocal of negative 3. But if I multiply by negative 1/3, just keep in mind, that is the same thing as dividing row 2 by negative 3. So if I just say divide the whole row by that same number, that's exactly the same thing as multiplying by the reciprocal. Okay, so let's go ahead and do that operation. 0, negative 3, 3, and 9. So all I'm going to do is divide everything by negative 3. Or if you want to say it as multiplied by negative 1/3, it's going to be the exact same thing. So that's going to give me a 0, that's going to give me a 1, that's going to give me a negative 1, and that's going to give me a negative 3. So I'm going to write my new matrix that we got right here with my new middle row. So my new middle row is going to become 0, 1, negative 1, and negative 3. And I'm just going to bring down the other two. 1, 1, negative 1, negative 3. And my last one, which is 0, 5, negative 4, and negative 2. So the first step in the process was to make this one a 1. We did that. Well, it was already a 1. Second step in the process, we need to make the 2 in the bottom on zeros. Third step in the process, we need to make the 1 in the middle into a 1. And now we're going to go into the fourth step. The fourth step of this process is that we need to make the number right below that 1 into a 0. And once again, to make that number into a 0 means we want to cancel it. And cancel it means that we want to add it. We want to use the process of addition so we can cancel it. So we're always going to add it to the equation that we made into a 1. You always add it to the 1, which is to the middle equation in this case. So we're going to add the second equation and the third equation. Keeping in mind that I want to cancel that 5 or make it a 0. Can make it a 0 means I want to cancel it. So in order for these two, the 1 and the 5 to cancel, first thing we need to do is we need to multiply this equation by the opposite of 5, which is negative 5. So negative 5 is going to first be multiplied by each one of these. Negative 5 times 0 is 0, then we get a negative 5, then we get a positive 5, and a positive 15. And then to cancel it out, we now need to add it to this equation right here, 0, 5, negative 4, and negative 2. So we're going to add them together. So then we're going to get 0 plus 0 is a 0. Negative 5 plus 5 is a 0. 5 plus negative 4 is a 1. And 15 plus negative 2 is a 13. And we're going to put those values in the middle row, which is what we changed right now. Because what we wanted is, well, not the middle row, the third row, because we wanted to make that 5 into a 0. So we were working on the bottom. 0, 0, 1, and 13. And I'm just going to bring down the other two rows. 0, 1, negative 3, which is the middle row. And my first row, which is 1, 1, negative 1, and negative 3. Okay. So we already did make this a 1. Whoa, it was already a 1. Step 2, make the bottom two zeros. Step 3, make the middle one a 1. Step 4, make the one at the bottom into a 0. So we did all of that. And we need to do step 5, which is make the number in the corner into a 1. But as a surprise, the good thing is that is already a 1. So we don't need to do it. Okay? So those are the 5 steps that the Gaussian elimination is going to consist of. So all of this that we just did right here, this is a process called Gaussian elimination. But there is one more thing to it. That Gaussian elimination consists of 2 parts. It is called Gaussian elimination with back substitution. I'm going to show you what that back substitution means. Okay? What is the goal of this problem? To find the solutions for x, y, and z. That is the actual goal of this problem. So what you need to do next is that you need to write the 3 equations that you have from this system. looking at the three matrices, we need to write the equations back. So my first equation is read as 1x plus 1y minus 1z equals to -3. My second equation, now let's go ahead and read that out. My second equation is read as 0x, so there is no x, so it is just plus 1y, which is y, minus 1z, which is minus z, equals to -3. And then we need to read back the third equation. What does the third equation tell us? 0x, 0y, so that means no x, no y, and 1z, which means just z, equals to 13. So this is going to be called the back substitution. Now, what does the back substitution is going to mean? It means that to find the values of the variables, we need to substitute back the value of that z that we obtained into the other two equations one at a time to find the y and the x consecutively. That's what the back substitution consists of. So first we're going to go to the middle equation here to find the y. So it's y minus, and we already know that the z is equal to 13, so I'm going to put the value of z with the 13, and that equals to -3. And to solve for y, all we got to do is add the 13 to both sides. So that gives me y is equal to 10. So that's the value of the y. So we already know that y is equal to 10 and z is equal to 13. So how do we find x? We're going to go back to the first equation, x plus, and then we already know that the y is 10. So we're going to substitute the y with the 10 minus z. But the z we already know is a 13, so we replace the 13 back into the z, and that equals to -3. So right here we can combine like terms, right here, so it's going to give us x minus 3 equals -3, and to solve for x, which is going to add 3 to both sides, so that gives me x is equal to 0. And likewise, like that, we're going to find the solution to the system. So as you can see, the solution for this system of three equations is going to be the triple x, which is going to be 0, comma, y, which is a 10, comma, z, which is a 13. So that is the triple, the triple of intersection of these three linear equations. So this process, it is called again Gaussian elimination with the back substitution that you see in the bottom, because with the Gaussian elimination, all we can see is that we can see what z is equal to. So we need to substitute the answers to find the y and the x. That's what we need to do at last. Now, we're going to answer one last question, but on the next question I am going to show you the process of Gauss-Jordan elimination. So you can see the difference between the Gaussian elimination with back substitution and Gauss-Jordan. Okay. So I'm going to be showing you the Gauss-Jordan. So we're going to start it in the exact same way with the same 5 steps at the beginning. Okay. So, but now we're going to focus on this one. We're not going to do the first method. We already did that. Let's solve the system using Gauss-Jordan. So, first step in the process again is that we need to write the augmented matrix for this. Let's write the augmented matrix. So my augmented matrix is 1, 5, and then right here is a 0 because there is no z, and then the constant is a 0 on the right side. For the second one, we have a 1, a 6, and then we have a 1 for the z, and then a 1. And the last one, 3, -1, -1, and -46. So, we're going to do the row, again I'm going to show you all the row operations as we go. First step into the process is this, that we need to first make that top number into a 1, but it is already a 1 again. So we're going to go directly to the second step. Okay. So I'm going to copy the first row because the first row, it's already a 1 there. So we don't need to do anything there. Second step in the process now is that we need to make the two numbers below that 1, we need to make them zeros. Okay? So we're going to start with 1 at a time. To make it a 0, if I want to make that 1 a 0, means I want this to cancel. So to cancel, I need to use a process of addition. And you're always going to add it to the equation that we made into a 1. You always add it to the 1. Okay? So we're going to add the first and the second equation. So 1, 5, 0, and 0 is going to be added to 1, 6, 1, and 1. So if I want to make this one a 0, what do I need to do first so that they cancel? Multiply the other equation, the one that has the one that we made a 1, by the opposite of that, which is negative 1. Right? So if I multiply a negative 1 times all of this, all that's going to happen is that it's going to change the sign. So that's going to become a negative 1, negative 5, and the 0 and the 0 are going to stay the same. Then we're going to bring this other equation, and what we're going to do to them is that we're going to add them. Right? So we're going to add these two. Negative 1 plus 1 is a 0, negative 5 plus 6 is a 1, 0 plus 1 is 1, 0 plus 1 is 1. So my second row is 0, 1, 1, and 1. Let's write the operation. I want you to write the equation for these operations that we just used here. We multiplied negative 1 times the first row. So I'm just going to say negative R1. That means negative 1 times R1. And then we added it to the second row, plus row 2. Now, let's do the same thing now to make that 3 on the bottom into a 0. So to make that 3 into a 0, what we need to do, we need to add it to the equation that we just made into a 1, which is to the first equation. So we're going to add the first and the last equations. So 1, 5, 0, 0, we're going to add it to 3, negative 1, and negative 46. So if I want to make that 3 into a 0, what I need to do first is that I need to multiply this equation by the opposite, which is a negative 3, so that they can cancel. So we multiply a negative 3 times all the values in this row. So that's going to be a negative 3, negative 15, 0, and 0. And then what we need to do is we need to add them to this row. 3, negative 1, negative 46. So we're going to add them with each other. So negative 3 plus 3 is going to be a 0. Negative 15 plus negative 1 is negative 16. So we get 0, negative 16. Then 0 plus negative 1 is negative 1. And then 0 plus negative 46 is negative 46. So far we have the first two steps. We made the top one a 1, and we made the bottom one zeros. Step number 3. You need to make the one in the middle a 1. But as a surprise, what do we see is that it is already a 1. So we're going to skip that, and instead now we're going to go to the fourth step, which is we're going to make the negative 16 into a 0. Now once again, how do we make a number in the matrix into a 0? We're going to use a method of addition, meaning that we're going to add it to the equation that we made into a 1, which is to the middle equation, the middle row. Okay. Oh, before I do that, I forgot the equation. For this one right here, what did we do to get the new values on the bottom? We multiplied the first row by negative 3, and then we added it to the last row. Now let's go ahead and do the next operation. To make that 16 a 0, I'm going to add it to the equation that has the 1, which is the middle equation. So it's going to be 0, 1, 1, and 1. It's going to be added to 0, negative 16, negative 1, and negative 46. So to make that negative 16 a 0, or cancel it with the 1, first thing we need to do is multiply this 1 by the opposite of negative 16, which is positive 16. So we're going to multiply everything by 16 in the first row, and if I do that, that is going to give us 0, 16, 16, and 16. and then those are going to be added to these values: 0, -16, -1, and -46. So we're going to add them together, and that is going to give us a 0, 0, 15, and -30. So let's write down the new matrix, and on that new matrix, the last row is going to be changed to those new values. We're going to put 0, 0, 15, and -30. And then I'm just going to bring down the other two rows, which is the 0, 1, 1, 1, and the top row, which is 1, 5, 0, and 0. So far you see that we followed the first 4 steps. We made this a 1, we made the bottom 2 zeros, we made the middle one a 1, well, it was already a 1, and we made the bottom one 0. Now the fifth and last step of the Gaussian elimination is that we need to make the 15 into a 1. So anytime I want to make a number into a 1, keep in mind what you do. You just have to divide the whole row by that same number, or multiply by the reciprocal of 15. The reciprocal of 15 is 1/15. So I can either say multiply the third row by 1/15, or, which is the same thing as divide row 3 by 15. That's basically the same thing. So let's do that next. So the third row, 0, 0, 15, and -30, I'm going to divide everything here by 15. That's going to give us a 0, a 0, this is going to give us a 1, and this is a -2. So we're going to write down the new matrix right here, in which the bottom row is going to be a 0, 0, 1, and -2. And we're just going to bring down everything else, which is 0, 1, 1, 1, and the top row, which is going to be a 1, 5, 0, and 0. So if we would do the Gaussian elimination with back substitution, we would be done. We just need to do the back substitution. However, I'm going to show you the next method, which is the Gauss-Jordan elimination. It's a little extension that we're going to do, a little extension of the Gaussian elimination. So for Gauss-Jordan, so after you make the 1 and then the zeros, then the 1, then the 0, and then the 1, the last 2 steps, you're going to add 2 more steps. You're going to make the top 3 numbers zeros. Okay? That's basically what the Gauss-Jordan elimination is. You will see what is going to be special about it. So first we need to make that 5 a 0, and then we make these 2 zeros. Okay? Let's start with the 5. So if I want to make the 5 a 0, remember what the procedure was. You need to add it. To make it a 0 means I want to cancel it. To cancel it, I need to use the process of addition. And the process of addition means that you need to add it to another equation. And you're always going to add it to the equation that has the 1, which is going to be the middle equation again. So we're going to add the first and the second equation. So 1, 5, 0, 0 is going to be added to the second equation, which is 0, 1, 1, 1. So if I want to make that 5 into a 0, I need to multiply the bottom equation by the one by the opposite of 5, which is -5. So -5 times 0 is 0, then this becomes a -5, -5, and then -5. And then you need to put it together with this row right here, 1, 5, 0, 0. So we're going to add them together. So when I add them, 0 plus 1 is a 1, -5 plus 5 is 0, -5 plus 0 is -5, and -5 plus 0 is -5. So we're going to copy those numbers into the first row. So the first row becomes 1, 0, -5, and -5. And I want you to tell me what is the operation that I used to make that a 0 right here. I multiplied the second row by -5, and then I added it to the first row. Let me bring down everything else. 0, 1, 1, 1, and 0, 0, 1, and -2. So you see that so far we made the 1, we made the zeros here, we made the 1, we made the 0 here, we made the 1, and we made the 0 here. Step number 7 and last is that you need to make those two numbers zeros. And we're going to do one at a time, of course, because there's two of them that we need to make zeros, but we're going to do one at a time. Okay. So the first one, I'm going to make a 0. I'm going to do the -5 a 0. So to make it into a 0, we're going to use again the process of addition, which is you're going to add it to the equation that you made into a 1, which is to the last equation. This one is, we want to make it a 0, so that's not the one you need to add it to. You add it to the one that you made into a 1, which is the last row. Okay, so we're going to do this, which is add the first and the last rows. 1, 0, -5 and -5 is going to get added to 0, 0, 1, and -2. Now the question is, in order for the -5 and the 1 to cancel, first I need to multiply the 1 by the opposite of -5, which is +5. So that gives me a 0, 0, 5, and -10. And then you're going to put it together with this equation, which is 1, 0, -5, and -5. So when I add them, that is going to give me a 1, 0, 0, and then -15, and that is my first row. 1, 0, 0, and -15. And before I proceed, I want to ask you to tell me what is the operations that we use to get these numbers to become these. We multiply the third row down here on the bottom by -5, I mean not by -5, by +5. So we multiply the third row by +5, and then we added it to the top row, which is the row 1. Okay. Last but not least, now we need to make this one in the middle a 0, and you always make it a 0 by adding it to the equation that you made into a 1, which is to the bottom equation. So we need to add it to the bottom row. So the middle one, which is a 0, 1, 1, 1, is going to be added to the bottom, which is 0, 0, 1, and -2. So if I want this 1 to become a 0, in other words, to cancel with the 1, first we need to multiply this bottom 1 by the opposite of 1, which is -1, and then we add them. So if I multiply it by -1, we're going to get 0, 0, -1, and +2. And these must be added to 0, 1, 1, and 1. So we need to add them to these. So when I add them, we're going to get 0, 1, 0, and 3. So those are going to be the new values in my middle row. 0, 1, 0, and 3. And what are the operations that we use to change these numbers into this? Well, we multiply the bottom one by a -1. So we're going to say -R3. That means -1 times R3. And then we added it to the second row. And then I'm just going to bring down the last row, which is 0, 0, 1, and -2. If you look at all the numbers on the left side, all of them are 1s, 0s below, and 0s above. This is called Gauss-Jordan Elimination. Okay, that's what it's called by Gauss-Jordan Elimination. Now, if I ask you to do this, translate the first equation, the second equation, and the third equation, what do they tell me? This means 1x, which is just x, no y, and no z, and then equals -15. So as you can see, this already gives me the value of x. Look at the second equation. No x, 1y, which is y, no z, equals to 3. So this automatically gives me the value of y, and no x, no y, 1z, and that is z equals to -2, and that automatically gives me the value of z. So that means that the solution for this system of equations it is going to be the order triple, x, which is negative 15, comma y, which is 3, comma z, which is negative 2. And this completes this problem. You could have done it with Gaussian elimination with back substitution by stopping right here and then writing the three equations and then substituting the z with the number negative 2 and then the whatever y you get into the first equation to find x. You could have done that, the Gaussian elimination with back substitution, but what I do highly recommend is, since we're going to be using this process in later sections, so I do recommend that you practice in doing the Gauss-Jordan elimination instead of the Gaussian elimination with back substitution. So this problem concludes section 9.1.